Welcome to the lesson on implicit differentiation. In this lesson, we will learn how to differentiate or find the derivative of functions that are defined implicitly. The functions that you see here are examples of functions that are defined explicitly. As you see here, y is explicitly defined in terms of x. So we have all x here. This is our function y, and this is in terms of the variable x. In the previous sections, we learned how to differentiate these type of functions. Now for this section, we will learn to differentiate or find the derivative of functions like this. These are examples of functions that are defined implicitly. As you see here, y is not explicitly defined in terms of x. Now, to find derivative of such functions, we will follow the following steps. Our first step is to differentiate both sides of the equations with respect to the variable x. And remember to use chain rule, such that when you differentiate y in terms of x, you will then write dy dx. Or you differentiate, for instance, when you differentiate y cubed, you would differentiate it as 3y squared dy dx. Now, after you differentiate both sides of the equation, you will then solve the resulting equation for dy dx. To illustrate this, let us consider the following examples. Find dy dx by implicit differentiation. So as a first step, we will differentiate with respect to x both sides of this equation here. So we'll differentiate 10x cubed minus 2y to the fifth equal to negative 6, and differentiate that with respect to x. So we differentiate both sides of the equation. So let's apply, or let's differentiate each term here. The derivative of 10x cubed is 30x squared. Then next, differentiate negative 2y to the fifth. Now to differentiate this, since y here does not agree with the variable here, you have a y here and you have an x here, that means you are going to use chain rule. Remember, when you differentiate something of the form u to the n with respect to x, the derivative of u to the n with respect to x using chain rule is n u to the n minus 1 times the derivative of this u here with respect to x. So times du dx. Now applying that to the term here, we get negative 10. So that means negative 2 times 5. So you bring down 5, you multiply 5 to the constant here, you get 10 or negative 10. And then you subtract 1 from the power here. So you have y to the fourth. Now since we are using chain rule, then we write the derivative of y with respect to x. So you put dy dx. Again, you use chain rule here because we have a y here and we're differentiating it in term or with respect to x. And then the right hand side will just be equal to 0 because the derivative of a constant is 0. Then as a next step, you will solve for dy dx. Now to do that, we will transform 30x squared to the right hand side or to the other side of the equation. So you have negative 10y to the fourth dy dx is equal to negative 30x squared. Since you want dy dx, you will then divide both sides of the equation by negative 10y to the fourth. And then this cancels out. We have dy dx on the left-hand side, and this is equal to, now you simplify also, negative 30 divided by negative 10 is positive 3. So you have 3x squared over y to the fourth. Number 2, find dy dx in this equation here using implicit differentiation. As a first step, we differentiate both sides of the equation with respect to x. Now, when you differentiate this side here, you will use the product rule. You use the product rule because you will consider this expression here as one factor and this expression here as another factor. So you are multiplying x squared and y to the fifth. They both have different variables, so we will use a product rule here. Now, using a product rule, you copy first one factor, that is x squared, times the derivative with respect to x of y to the fifth, plus you copy y to the fifth, and then you differentiate times the derivative with respect to x of x squared is equal to, now the derivative of this is just 0. The derivative of constant is 0. Then let's perform the differentiation here. We have x squared times, now the derivative of y to the fifth with respect to x is equal to 5 y to the fourth dy dx, because we use chain rule here. Why did we use chain rule? Because we have y here and y does not agree with x. So same as this formula here, where it's like we're differentiating u with respect to x. So u to the n with respect to x. The derivative of u to the n with respect to x is n u to the n minus 1 times du dx. So we just applied it here. The derivative of y to the fifth is equal to 5 y to the fourth, so 5 minus 1 is 4, times the derivative of this variable with respect to x, plus, and then you copy this, y to the fifth, times the derivative of x squared is just 2x, equal to 0. And then you solve for dy dx. You transpose this term here to the other side of the equation. So you have 5x squared y to the fourth dy dx is equal to negative 2x y to the fifth. And then you divide both sides of the equation by this expression here, 5x squared y to the fourth. And so therefore dy dx is equal to negative 2xy to the fifth divided by 5x squared y to the fourth. Now for our third example, when you differentiate this side here, you will also use product rule. Use product rule because you have one term or one expression here that is in terms of x and another expression that is in terms of y, and they're being multiplied together. So to get dy dx, let's differentiate both sides of the equation here. We have x squared times the derivative with respect to x of ln y plus, so using product rule, copy ln y, times the derivative with respect to x of x squared equal to the derivative with respect to x of 1. So we have x squared. Now the derivative of ln is 1 over y. The derivative of ln the derivative with respect to x of ln is equal to 1 over u du dx. So therefore we have 1 over y dy dx plus ln. Now the derivative of x squared is 2x is equal to 0. And then we transpose this on the other side of the equation and solve for dy dx. We have x squared over y dy dx. For this side here, you just multiply x squared times 1 over y. That is x squared over y. Then copy dy dx. Then this one, when you multiply this to the whole expression, not only to y. So that is equal to negative 2x ln y. And then therefore dy dx can be computed by multiplying both sides of the equation by the reciprocal of the expression here. So you multiply this by y over x squared, and then you do the same thing on the other side of the equation. So if you multiply this by the reciprocal of this, so you have that is equal to 1, you can cancel them. So therefore dy dx is this product here. So that you can simplify that to negative 2xy ln y divided by x squared.